Let's look at this 11th one. Integral of x cube dx divided by square root of 4 minus x to the power of 8. Now here, what should be the substitution? We know that when we differentiate x to the power of 4, we will get x cube dx. So let's do that. So u is equal to x to the power of 4. Du is equal to 4x cube dx. That means x cube dx is equal to du by 4. So after substitution, we get 1 by 4 integral of du by square root of 4, we can write it as 2 square minus u square. And this we know, a square minus x square under a square root in the denominator is sine inverse of u by 2. So 1 by 4 sine inverse of u by 2. Substituting back, we get 1 by 4 sine inverse of x to the power of 4 by 2 plus c. 12th one, integral of cos x dx divided by square root of 9 plus 4 sine square x. Try to find a pattern here. This can be written as 3 square plus 2 times sine x square. So that means a square plus x square we get. So that means we can do the substitution u is equal to 2 sine x. So that du is equal to 2 times cos x dx. Or cos x dx is equal to du by 2. So after substitution, we end up with 1 by 2 integral of du by square root of 3 square plus u square. And we know that the integral for this is 1 by 2 natural log of absolute value of u plus square root of 3 square plus u square plus c. Of course, we need to remember that that is what this is. Now we substitute back u. We get 1 by 2 natural log of absolute value of 2 sine x plus square root of 9 plus 4 sine square of x plus c. Now let's look at the 13th one. Integral of dx by x square minus 4x plus 1. Now in the denominator, we have a quadratic. Remember, we have already derived, depending on the discriminant, the formulas. So when d is greater than 0, when d is equal to 0, and when d is less than 0, we have arrived at 3 different formulas. So here in the denominator, we have a equal to 1, b equal to minus 4, and c equal to 1. And b is equal to b square minus 4ac is equal to 12, which is greater than 0. So when it is greater, we require square root of d, which is equal to 2 root 3. The standard formula for d greater than 0 is 1 by square root of d natural log of absolute value of 2ax plus b minus root d divided by 2ax plus b plus root d plus c. So we apply that formula. We get 1 by square root of d is 2 root 3. So 1 by 2 root 3 times natural log of 2ax. A is 1. So it becomes 2x. B is minus 4. So minus 4 minus root d. So minus 2 root 3. Divided by 2x minus 4 plus 2 root 3 plus c. Now here you notice in the numerator and the denominator, each of the terms has a common factor 2, both in the numerator and the denominator. So we take it out. We get 2 by 2 as the common factor. They cancel out. So that we are left with 1 by 2 root 3 times natural log of absolute value of x minus 2 minus root 3 divided by x minus 2 plus root 3 plus c. 14th one. Again, a definite integral. Integral from 0 to 1 by 2 of dx by square root of 3 minus 4x minus 4x square. Let's see. Let's take care of the denominator inside the square root. Simplifying it, we get 4 times 1 minus x plus 1 by 2 the whole square. And this 1 can be looked at as 1 square. So now our original integral has become integral from 0 to 1 by 2 of dx by square root of 4 times 1 square minus x plus half square. Now, this 4 is under the square root. We take it out, it becomes 2. It's a constant, so we take out 1 by 2 out of the integral. So we have 1 by 2 times the integral from 0 to 1 by 2 of dx by square root of 1 square minus x plus half square, which is again in the form of a square minus x square. So we know what the integral is, 1 by 2 sine inverse of x plus 1 by 2 by 1 from 0 to 1 by 2. And this x plus 1 by 2 by 1 I have written just to follow the formula. But in the denominator, we don't have to show the 1. So we have 1 by 2 sine inverse of x plus 1 by 2 from 0 to half. Now actually taking care of the limits. 1 by 2 times sine inverse of 1 by 2 plus 1 by 2 minus sine inverse of 0 plus half. So that it becomes 1 by 2 times sine inverse of 1 minus sine inverse of 1 by 2. Remember, for what value of the angle will sine be 1? So sine pi by 2 is 1. So pi by 2. And for what value of sine do we get 1 by 2? For pi by 6. So we have 1 by 2 times pi by 2 minus pi by 6. So pi by 2 minus pi by 6 is 2 pi by 6. So 2 cancels out and we are left with pi by 6. So the value for the definite integral is pi by 6. 1. Integral 2x plus 3 dx divided by x square plus 2x plus 2. Here it's a little bit tricky because if we take u is equal to x square plus 2x plus 2 and we differentiate it, we get du is equal to 2x plus 2 dx. But what we actually have is 2x plus 3 dx. So what do we do? What we do is split this 3 into 2 plus 1. So that integral becomes integral of 2x plus 2 plus 1 divided by x square plus 2x plus 2 dx. And we split this as two separate fractions. In one fraction, we have integral 2x plus 2 by x square plus 2x plus 2 dx plus integral 1 by x square plus 2x plus 2 dx. So here the first one, based on this substitution, becomes integral du by u plus, and this becomes integral dx by x plus 1 the whole square plus 1. And solving the integrals, we get integral du by u is natural log of absolute value of u plus this is in the form dx by x square plus 1, which gives us plus 1 by 1 tan inverse of x plus 1 by 1 plus c. Or simplifying it and bringing back the x terms, we get natural log of absolute value of x square plus 2x plus 2 plus tan inverse of x plus 1 plus c. So that was the 15th one. Now let's look at the 16th one. Integral dx by square root of x square plus a square. Now here we substitute x with a tan theta. Now why a tan theta? Primarily because here it would become a tan square theta. A square and a square are common, so it will come out of the square root as a. And inside the square root, we will end up with tan square theta plus 1, which is sec square theta. Okay, so differentiating we get dx is equal to a sec square theta d theta. Now tan theta is equal to x by a, which means theta is equal to tan inverse of x by a. Now, carrying out the substitution, our original integral becomes integral dx is a sec square theta d theta divided by square root of a square tan square theta plus a square. A square common, take it out of the square root as a cancels out. So integral sec square theta d theta divided by square root of tan square theta plus 1. This becomes square root of sec square theta. The square and the square root cancels out. So in the denominator, we have sec theta. One sec theta from the numerator and this sec theta in the denominator cancel out. And we are left with integral of sec theta d theta. And we know the integral of sec theta, which is natural log of sec theta plus tan theta under the absolute signs plus c, which is equal to natural log of what is sec theta? That is going to be square root of x square plus a square by a plus tan theta is x by a plus c, which is equal to, combining these two terms, we get natural log of absolute value of square root of x square plus a square plus x, the whole thing divided by a plus c. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.